Okay, so I'm going to do the other ones really quickly in case you're just really having a hard time getting this. Remember, the things that we're looking for are to graph are x-intercepts, the y-intercept, the vertex, and once we get the vertex, that, if we draw a vertical line through it, gives us the axis of symmetry, and that helps us even get more points, so our graph is even more accurate. So these are the big ideas right here, and we're going to try to graph these equations that were in your homework that we changed the problems to make them a little easier. X squared minus 7x plus 12. Okay, so the first thing I'm going to do, I always like to find my x-intercepts first, because sometimes when I find my x-intercepts, I figure out that, oh yeah, that's the vertex, because I only found one of them. So let's do that first. I set y equal to 0 to find my x-intercepts, and I'm either going to factor it, or I'm going to use the quadratic formula, and here we can factor. Because if you think about it, 4 times 3 multiplies to give me 12. I need it to be a positive 12, and I need it to add up to negative 7, so it's going to be negative 4 plus negative 3 is negative 7, and negative 4 times negative 3 would be a positive 12 if I want my x-intercepts. If you say x minus 4 is equal to 0, and you solve for x by adding 4 to both sides, you get x equal 4. If you take x minus 3 and you set it equal to 0, and you add 3 to both sides, you get x equal 3. So now I know my x-intercepts are between 3 and 4. So I'm going to kind of make my graph a little longer this way. 1, 2, 3. Oh, that's not good. 4. Because I have to go up, look at my y-intercept up there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I know this is running up in my numbers, but let me do this. Let me graph in red. If my x-intercepts are 3 and 4, here's one. Here's the other. My y-intercept is just this constant on the end, so it's 12. That's why I had to go up there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So my y-intercept's going to be right here. I need to find my vertex. This thing's opening pretty quickly. So let's see. Let's find my vertex. Let's see. Once I find my vertex, I can draw my line through the middle, and I can get a really good approximation of where this thing is going. To find the vertex, if you remember, I get the x-coordinate of the vertex by going x equal negative b over 2a. Well, my b term is this negative 7 up here, so it's negative 7 over 2 times a is that 1 out front that's invisible. So it's negative 3.5. No, positive 3.5 because it's a negative negative. Couldn't read my dot there. So my vertex is at 3.5. If I want to know the y value, I've got to plug that x in to find the y value. So y equal x squared minus 7x plus 12. So probably going to want our calculator here because we're going to square 3.5. We're going to plug that in. You can type that in your calculator and get it. 3.5 squared minus 7 times 3.5 plus 12. I'm typing it in on one line in my calculator, and I'm getting negative 0.25. So it's negative 0.25. That means negative a fourth, doesn't it? So my vertex is like 3.5, which would be like here, and then down, let's say that this is negative a fourth would be just about right below there, wouldn't it? Okay, so since I've got let me color that in red because that's a part of the graph, okay? Now what I can do is draw in my axis of symmetry through the vertex. It's a vertical line through the vertex. It has an equation. It's the same x as the vertex, so its equation would be x equal negative 3.5. It's going to match up with, be positive 3.5. It's going to match up with this x in our vertex. We haven't talked too much about that yet. That's okay. And so let's see. I didn't go far enough over on my graph because if I've got a point, look at this red dot on the y-axis over here. If I got a point that far over from the middle, then there'll be another one over here. It's going to be off the graph, isn't it? I'll kind of generally put it here, but you'd have to count the same distance over, and I don't have enough room. I can try to cram it on there a little bit. This one seems to me to have kind of a weird shape. You might want to go put another value in. For instance, if I want to make sure that I've got a good feel for the shape of this, I could come in and say, well, what happens when x is 1, for instance? Well, the y value would be 1 squared minus 7 times 1 plus 12, which would be 1 minus 7 is negative 6. Negative 6 plus 12 would be 6. So I could say, oh, I got a point at 1, 6. 1, 2, 3, 4, 5, 6. So that's like right here. And if I've got a point that far over this way, I'll have another one about over here. Adding more points can help you if you think you need a little bit more to get a good graph. Now, there's a stray mark up here. I'm going to scribble it out like that. That doesn't go with it, does it? But I graphed it. What did I use? I found my x-intercepts by solving the equation by setting it equal to 0 and factoring. My y-intercept was the number on the end. I used this little equation right here, x equal negative b over 2a, to find the x-coordinate of my vertex. How did I find the y? Once I find the x, I take the x, I plug it back in for x in the original equation and solve for y. Use your calculator when you have weird ones like this. And when I get the y, I can go graph it. And then I've got my vertex. I can use that vertex to draw an axis of symmetry and go the same amount over. If you get a point and it's so much over, you know on the other side of that line you've got another point that much over. So basically, here's what your graph for number 9 can look like. Next, I thought we'd do what we changed number 11 to be. I think you guys kind of freaked out a little bit because the simplification process in a lot of the stuff was hard. So I tried to change the problems where you could get the idea without the answers looking so weird. So for 11, we changed it to x squared minus 6x plus 8. Okay. So first, I'm going to get my x-intercepts. I'm going to factor it and set y equal to 0. Well, this one I chose to factor nicely too. It should be x minus 4 times x minus 2, because negative 4 times negative 2 is positive 8, and negative 4x plus negative 2x is negative 6x. All right, if I want to solve for the x-intercepts, I set each factor equal to 0. That means I'm going to get x equal 4 is one x-intercept, and x equal 2 is another x-intercept. So these are my x-intercepts right here. My y-intercept, I'll kind of change colors just so you can kind of keep up with the change in thought process, since it's kind of hard. I want to get everything on one page so we can graph it. The y-intercept is just the constant c, the number on the end of the equation. When I solve for y, it is 8. Okay, so I need to be able to go up to 8, at least I know that. And now let's talk about our vertex, and we'll go graph all these things. The x-coordinate of my vertex I find by plugging in negative b over 2a. Up above, my b is negative 6. My a is the invisible 1. I'll write it out front. So that's 6 over 2 equal 3. So my x-coordinate is 3. How do I find my y? I plug it in. So I'm going to go back to the equation, because remember, this is the equation I'm working with. I'm going to plug in my x and find the y that goes with it. That's always what we do. When we plug x's in, we find the y's that go with them. So if x is 3, let me plug it in. That would be 3 squared is 9. 6 times 3 is 18, but I'm subtracting it, and then I'm adding 8. Let's see, 9 minus 8 is negative 9, plus 8 is negative 1. So my vertex, there's the y that goes with the x I plugged in. It's negative 1. All right, so I got lots of stuff here I can graph now. I want to make sure I can go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm trying to make marks that are pretty as even as I can get them. Okay, so there's my graph. Here's my x-axis. Here's my y-axis. In black, I'm going to graph my y-intercepts. They were 4 and 2. I found them above, so here's 2. X is 2, and x is 4. Then I had my y-intercept was 8. I'll graph that in green since I wrote that in green. 1, 2, 3, 4, 5, 6, 7, 8. These are all points on the graphs. And then my vertex down here, I'm going to choose purple and circle this in purple. 3, -1 would be right here. Once I get my vertex, remember, one thing that can help me graph is to go straight down the middle through the vertex. That's a vertical line. And if you look, aren't my x-intercepts the same distance apart from the line? They're 1 from the vertex. The vertex x was 3, and that one's at 2, and that one's at 4. If I have up here, the y-intercept was about this distance away, so I'll go about the same distance away and put another point in up here. I can just fill it in. That little purple squiggle was not part of the graph. I'm going to draw the graph in red just so you can exactly see. I'm going to try to round the bottom of it to make a U. Don't want to make it look like a V. There's my graph. So that's, if you look at it, we've done all of them now that I assigned. I changed the assignment. We either did them in class or you did them maybe by looking at the videos if you needed help.